All right, so we will be going over several frequently asked questions that you may have throughout the length of these talks. Of course, this doesn't cover everything, so by all means, please continue to ask questions when we're done with the talk. So a lot of what we're going to talk about today has perhaps already been mentioned or discussed by someone else in the previous talks, but these are things that are quite common issues or scenarios that you are likely to encounter. So first and foremost, when it comes time to preparing for your observations, you want to make sure to talk with your support scientist, the person that's been assigned to you. If it will go back. There we go. If there are any problems you think you're having or you're not confident with your scripts, just like in our sessions before observations, we are there to talk with you about what you're hoping to accomplish and whether or not the script that you've written will do that for you. And then when it comes time to observe, remember, you need to go onto the DSS website and enable not only your project, but any relevant observers. Without both of these things, your project will not be scheduled for an observing time. Also, it's important to keep track of what receivers are going to be available throughout the semester. Since we only have limited space up on the telescope, we are routinely swapping receivers in and out of work. So that information is also available on the DSS website, and you can find out if or when a particular receiver is actually going to be available to observe a project that you want to do. And then, of course, you have the different ranks that Will mentioned. A-ranked projects have a full year in which to be performed. B-ranked projects only have the semester that they were selected for. Now, when it comes to actually writing your scripts, something that hopefully everyone has been learning about the past few days is make sure you document your scripts. It's really easy to forget, but it makes things so much easier, both for the support staff who might be reading through your scripts to help you find a problem, and even for you or a collaborator down the line when it comes time to reuse that script for a similar project. All of the documentation can use is commented out using the pound sign, aka the hashtag or the octothorpe, and make sure that every time you use a frequency value in the script, it's in megahertz. Some other things to keep in mind, some of you may have experienced the other day, as well as tonight, is RFI. Be sure to check if there's a possibility that there's RFI, radio frequency interference, that is going to impact your observations. On our website, we do have a very complete and routinely updated list of expected RFI signals, their strength, and so forth. Then when it comes time to actually performing your observations, it's generally suggested to calibrate at the beginning of your scripts. That way, if something goes wrong, some of the Pulsar students knew about that from Tuesday early morning. You at least have those values. However, depending on your situation, that isn't always the best thing to do. So you can calibrate at the end, but you just need to be aware of the risks. Now, when it comes time to doing those calibrations, it's important to choose pointing calibrators, specifically, ideally in the GBT pointing catalog, and in the relevant band for you. That way, Some of these sources can also be cross-referenced with the VLA flux calibrator manual in order to check your calibration. Now, in some cases, like much higher frequencies for W-band or Argus, it's possible to start at a lower frequency to find your pointing calibrators, just because it's much easier to lock in the general pointing before you move to the much higher frequencies, where you could be way off and no way of telling just where you need to be pointing. Now, this mentions that with high frequency and in poor weather conditions, it's ideal to use relaxed heuristics. Actually, as of just a short while ago, we have now officially stated that relaxed heuristics are standard for all observations above 27 gigahertz. So this is still something that you can go into the Astrid pointing options tab, and you can refine, which you can see in this window down below, between standard or relaxed. It may not have been mentioned, but user defined is another option, which we do not recommend unless you are a GBT expert, because it can potentially mess things up. But in general, relaxed heuristics is a pretty safe mode. If you are unsure, you can always talk to your support scientist. Again, under the tool options, you can directly input corrections for the as and L if there's an issue or you need to actively refine them yourself. And then, right, so again, along with making sure that you have an observer in your project validated on the DSS website, you also need to make sure that your scripts are active and ready to go before you do those final checks, because once your project is enabled, it can be set to observe within 48 hours. Then you don't want to be scrambling for scripts or showing up with incomplete scripts right before it's time for you to observe. There are a lot of really general things that it's important to double check, like making sure that your LST ranges are correct, so that you can actually be observing your object in the time that's been scheduled, and you're not wasting the telescope's time or your own time waiting for a source to rise. Be sure to keep your blackout dates up to date, so that we don't accidentally schedule you at a time that you or any of the other observers assigned to the project cannot observe for. And keep contact information up to date so that if there is a problem or when we do schedule you, you get that information. Now, something we've also been hopefully showing you during your observations the previous night is you want to get online and test access to this telescope well in advance of your observations so that you know there aren't going to be any surprise problems. Making sure you remember the date and time is hopefully a no-brainer, but yes, always be sure that you are able to get to the telescope to connect in a timely manner. So this generally includes signing in about 30 minutes prior to your start time so that you can do all of the above. You can test your connection, you can make sure that your scripts are ready to go, and you can even be ready in case the project before you ends early. You might get a little bit of extra time out of it. And a last few final important reminders is do not use someone else's account. Even if you're observing with them and they already have theirs open, you need to use your own account. So this is about, pun intended, accountability for who is using the telescope at a given time. Failure to comply with this is that you could actually get banned. Also make sure that your session numbers within a project aren't duplicated, or you risk losing some previous data. And lastly, just when you are actually observing, be sure to check on your data in real time when it becomes available using GBT IDL and the displays available in Astrid to make sure that you catch a problem if it arises, or any other problems that your observations are experiencing. And with that, I'm going to turn it over to Amber to talk about the next section, the operators.
All right. So this is the door that none of you have actually seen because you can't actually go into the control room, but this is the door to the control room. Go ahead, I'm going to let Jesse control it so that we don't have to switch control. So about the operators. So I was a former operator, and so I understand their point of view on a lot of things. And so I try to bring that to my new observers. So be nice to them. Some of them, actually, I don't think any of them have degrees in astronomy or physics. They, you know, a lot of them are mostly like they were military, they're ex-military. They've worked like in radio observatories, but like for the military and stuff like that. So like, don't assume that they're going to know everything. They know a lot, and they probably know a lot more details about the telescope's inner workings. But like asking them, like, does this look good? Does that, you know, those are things you shouldn't really be asking them because they don't really know. And you just want to try to in general be nice to them because they are sitting there for 12 hours and they are dealing with like multiple telescopes and multiple people, and they are like they're technically the security person for the site as well as like 100 other things. So sometimes, you know, they're just really busy. As I think I said in one of my other talks, the operators will always tell you when you're ready. Don't interrupt them to ask. It just takes longer if they have to stop the process of setting up the telescope for you in order to type to you and tell you that they're still working on it. And as I've said before, some of the operators are hunt and peck and they type like this, and it might take them a little longer to respond. Unless your project is operator run approved, they cannot run it for you. So you cannot so when I say this, we have certain projects that are operator approved, which means they have been given very detailed instructions to the operator and has been approved by the operations manager and by Tony, and the operators have looked at it and agreed that it's something that they feel confident that they can do. This is not the same as say, so this means you cannot log in, say, I have to go, can you run this for me? They will not do that unless it's approved to do that. What you can do, however, is log in, start your project and say, hey, I gotta run out. I gotta go do something. Give me a call if something happens. Because in general, they're keeping an eye on everything. They're still watching because they're sitting there. But if you're going to leave or walk away, just let them know. They don't have a problem with that. They will give you a call if they need to. They will. The worst thing to do is walk away, and then they'll type to you thinking you're sitting at your computer and you're not. And then like they're just going to take control and start doing whatever it is they have to do. So they will not run it for you, but they will watch it for you or stop it for you sometimes if it needs to be stopped. Be clear and specific about any issues you were having and be specific about the exact errors. The good resources to ask if, I'm not sure, I wrote that and that doesn't sound right to me. In most cases, you're going to see errors or warnings. As we said, if something's worth worrying about, you can always ask the operator and they can tell you. And an example of this is I had a observer that messaged me and said, something is wrong. I said, what's wrong? They said, Guppy's not working. Guppy is our old pulsar processing unit, our back end. And I said, well, what's wrong with it? Why isn't they're like, it's just not working. So I had to end up calling our scientist who wasn't on call because he was the only one who could handle the pulsar back end. When he logged in and he asked what is wrong, he went into detail and explained to him what was wrong. And what it turned out to be was that he was using the wrong data screen to look at. So he was doing like incoherent, and he was looking at the coherent screen. So if he had told me what the problem was, I could have told him that that was wrong or that he was on the wrong screen. And we wouldn't have had to waste like a half an hour trying to get a hold of people. So just try to be specific when you have a problem, and the more specific, the better. They aren't there to fix any and all problems that should happen on the observatory property. So when you are visiting, but they should be the ones you always call. They will not, like if you see a car go down to down the observatory path with a bunch of hunting dogs in it, because this happens a lot, you should call them. They cannot fix it for you at that particular moment, but they will find somebody who can fix it, because this does happen. People go bear hunting in Green Bank, they put radio collars on their dogs, and then that obviously interferes with the telescope. So if you ever see something on site, just go up to the control, not even to the control, you can walk in the front door, there's a phone there. I have the extension here, 2341, and you can just call them and let them know, and they will take care of it. They'll call whoever they need to call at that point. All right, go ahead, Jesse. All right. This is going to be, I said you guys are going to have to hear this more than one time. This is my soapbox. Talk and draw. Do not hit that get attention button. I really wish we could just remove that and make it go away, because it should never be there. As I've stated before, none of you can hear it because you're not in the control room. And it's a lot easier to explain when you guys can actually hear it, because I will usually make you all listen to it in the control room. The operators, again, they're doing multiple things. They are taking care of multiple telescopes. Some of them aren't, like the fastest typers and things like that. Every time you log in, you log out. Every time you submit any line, anytime you hit enter, that honks in the control room. I really need to find a soundbite of what that sounds like. And it is annoying. If you're not talking to the operator, because remember, they're sitting there for 12 hours and they're working on multiple telescopes, or sometimes they're just, they have downtime. And so they might be looking at another screen doing something else. When they hear that horn honk, that's the note to them that they need to turn around and pay attention. If you start having a general conversation, let's say Jesse logs in, I log in. Hey, Jesse, how was your day? How are your kittens doing? Tell me about your kittens. Dave Rose does not want to hear about Jesse's kittens. He is a nice man, but he does not want to be listening to Jesse's kittens or talking about Jesse's kittens while, he's sitting there, because it's distracting him, and he's going to get to the point where he's just going to ignore us. And so when Jesse actually needs him, he's not going to pay attention. Or when I need him, he's not going to pay attention because he thinks we're just having a conversation. That's what that create new group button is for. Click that. You can name it whatever you want, and it will be whatever. And then you can add whoever you want to the conversation. Just don't add the operator. All right. Receiver change. So these do take time, especially if you're going from prime focus to Gregorian. And you will never know what receiver is on before you. It could be L band, it could be Argus. So you always have to understand that they will have to turn the turret. It can take up to 4 minutes is really what I would say is like literally you have to go from one end to the other. It doesn't take that long, but they do have to switch those. And then they have about 4 different places where they have to tell the system that they've changed the receiver, and they have to tell it what receiver. And then, as I say also that, it takes 7 to 10 minutes to retract the boom. So I can't remember if anybody had explained to you guys, and I'm sure you've seen pictures, actually the one big picture Will has of where the receiver cabinet is and stuff. That boom, when it comes out, it extends out over top of the Gregorian receivers. So if it's out, you can't use the Gregorian receivers at all. I have no idea what's happening right now, but the screens keep changing.
I'm just showing an image of the telescope.
Actually, wonderful. So the little box, Jesse, can you highlight the little receiver box with the mousy mouse? Nope, yep, that. So inside there is actually a whole feed arm that will swing out over top of that, and actually it will cover the sub reflector up top, so you can't even use that either. So that because it has to move so slow, takes about 8 minutes to go from out to in or in to out. So if somebody's doing a different optical using different optics than you, it might take them a little bit to change it. So you have to take that into account. Like I said, usually about 8 minutes is what it should take an operator to do a full-fledged project change. And they cannot change the prime focus feed on the fly. So the prime focus has a big box, and essentially we can put different feed horns on. We can put 340, 320, or 342, stuff like that. The box always stays up. It's the feed that we will change, and that cannot be changed on log in and you want to do 342 and 800's up, they cannot change that for you. You're going to have to just deal with it. You'll have to use the one that is up. You should also check, because Tony will put in the email he sends you which one you're supposed to be using or which one is up. All right, Jesse, go ahead. After observing, don't run over your time if you can avoid it. Like I said before, it happens. There's always going to be times where, you know, you might need an extra minute or so. You just have to ask the next observer. You know, and they're pretty much always going to be happy. They would want you to do the same thing for them. So they're pretty much always going to let you go, but you know, time is expensive. And so every second does count. So if you can avoid it, don't just assume that somebody's going to let you finish. You should try to finish on time whenever you can. You should always submit observer comments after your observations. I think Will pointed out that we don't get very many of these, even though people should be submitting them all the time. Because what will happen is so we had mentioned that you should submit them when you're done with the project. If you have a problem that is happening, you should also submit them then, because if you have had a continual problem for pretty much every session you've done and you don't tell us about it until the end, we can't fix it for you. So you don't need to put one in after every observation, but if something is consistently going wrong for you, you should submit one and contact your project friend and let us know so we can fix it before your end of your project. You should analyze your data in a timely manner, because if something happens, we'll give you that time back. So like, let's say you did, as my group learned, KFPA, and your data in the beginning looked bad, and you're not checking that. So, and you choose to wait 3 or 4 months, and now the next semester has started, and you check your data and you're like, oh no, that's not good. What am I going to do? There's nothing we can do, because you needed to check that before. And so Tony would have normally been like, fine, I'll give you the time back. You can, redo it. It must have been the weather or something. So the sooner you at least check your data to make sure it's good and make sure that everything makes sense, the more likely we're going to be able to give you that time back and help you out if there is a problem. Check for any problems you might need to work around for your next observing session. If you saw that there was a problem and it was something with your setup, make sure that the next time you have that, you've worked around that problem. Or like if you're doing a map and you can't finish your map in the amount of time, make sure like before you leave, you go in and change your session so that when you log in next time, you have it already ready, and it should, instead of starting the map all over again, it will start where you left off. Because you don't want to waste that time doing that whole part of the map over again. Well, there was one more point.
Sorry.
That's all right. I didn't read what it says. Maybe I've already said it. Oh, yeah. No, I did say that. You're right, Jesse. Go for it. For H1 observations and mapping, people are going to disagree with me here. Actually, the one person who probably will seriously disagree with me is not here. I would say you should always do a point focus, no matter what. I would say even if you're doing pulsars, it's a sanity check. My group had issues with KFPA pointing last night. I mean, you should always do that for pointing for KFPA, but if you're doing prime focus, that's like your first instinct that something's wrong, because those observations take 30 seconds. Each scan is 30 seconds. If you're running a pulsar observation that runs for 6 hours, you're not going to, I actually don't know how pulsar observations work. I think you can get, essentially you have to finish a scan for the data to show up for you to see it. And so if you're running it for 10, 20, 30 minutes, you can go 10, 20, 30 minutes before you know anything's wrong. So I always say do a pointing, even if you don't need that correction limit. It's a check for yourself. Okay, does everything look right? Because when you're supposed to be getting a Gaussian peak and you do KFPA and you get a straight line that is going upwards and has a cliff on it, that's not right. So I would say you should always be doing a point focus, but some people will disagree with me on that, but I say it's always a good sanity check. You should always also take a short spectrum. My group did this. We were doing mapping, but we did a very short track scan in the beginning to see if we could see what should be there. It's again, another sanity check, and make sure everything looks okay. Don't jump right into your 3-hour observation. You want to know before 3 hours have passed that something is wrong. Check your map starting and ending position. This is back to the thing I said before. You want to make sure that you're not doing it again. If you didn't finish your map last time, make sure you change that number, which is in the script, to say that you want to start here and end at your normal one and not start all over again. And as I said, the point spread should not be a square or a circle. It should be a Gaussian. If it looks like a square or a circle, it's wrong. And you need to either talk to the operator or the support scientist, because that's not how it's supposed to look. All right, go ahead, Jesse. So I'm not gonna be able to speak very well to this. This was a slide that Ryan had approved for me. It says, do not rebalance between a calibration scan of the noise diode and the sign scan of a pulsar of interest. I can't really speak to that because I don't do pulsar observations, but Ryan wrote that, so it should 100% listen to it. Also make sure that the Vegas.fold par file parameter and asterisk points to the correct file on the disk. Again, Ryan definitely knows what he's doing. You should 100% listen to that if you do pulsars.
Next so I can speak a little bit about the first point, which is just that, yeah, you don't need to rebalance because the noise diode is basically a point of reference between the calibration scan and the actual scan of the pulsar of interest. So you want to actually be able to compare the data and of that noise diode.
Gotcha. Next slide. Okay, weather. I do know that I'm probably going over it a little bit now, but I do want to cover this because I can't remember if Tony had covered this or not. There are weather restrictions with the GBT, not just because, as I know multiple people have said, if you're at higher frequency, the weather can affect your observations. There is also just weather that we have to be concerned about for the safety of the telescope. If there is a lot of snow, that doesn't affect a pulsar low frequency observation or an H1 observation. They don't care about snow. However, if the snow is sticky and is accumulating inside of the dish, we have these very thin aluminum panels that we don't want to bend. And we don't want it to continue to accumulate on there, because then it freezes and then it takes even longer to get it off. And so even though you might be able to observe through the weather or through the snow, the operator will probably stop you if the snow is sticky or heavy enough, because they're going to have to try to dump it out of the dish before it becomes a problem. So if it's snowing, this is obviously only a thing that you have to worry about in the winter. It's never snowed in the summer in Green Bank, as far as I know. But we do not want to have too much snow and ice build up on the GBT. Also, because especially if it's night and the operator can't see it, if it's starting to build up, it's going to be a real problem in the morning. There are cold weather restrictions. Anything below, if the temperature drops below 17 degrees Fahrenheit, they have to cut the slew rate in half. And then this is usually between December and February. This isn't going to happen again in the summer, but essentially that is because there is a very fine film of oil that runs across like the wheels and things like that, that once it reaches a certain temperature, instead of becoming a nice smooth fluid, becomes a glue and will rip things apart. I know I'm out of time. I'm still going to tell my story anyway. I was 2 weeks into being an operator. It was 14 degrees Fahrenheit. I tried to put the stow pin in, which is the thing that holds so that people can go up on the GBT. It's literally a giant piece of metal that they stick into a hole on the telescope so it can't move. I went to stick the pin in. It was too cold, and the grease they had used seized up and literally pulled all the mechanisms out from behind the telescope, or from behind the device. This meant that, and minus 17 degrees Fahrenheit, guess who had to go up onto the telescope and stand there and try to help them figure out, mostly because I was still in training, so they wanted me to learn it. But that is the only time in my life I have not been able to feel my hands. It was so cold. So there are very good reasons why they stop it at cold temperatures. And also, if it goes below 0, they will stop it altogether. If you go below 0, or I'm sorry, minus 10 Fahrenheit, they will not, they will just stop the telescope, because at that point, everything is a solid, pretty much. And they will resume again after the temperature has risen above 0 degrees. The telescope will be stowed, I think I had mentioned this before, for a sustained wind that is higher than 35 miles per hour. I can talk today. And a gust that is above 40 miles per hour. This is not only for the benefit of you as the observer, because this means that the top of the telescope is probably moving. It is also, again, we have a giant thing hanging around up there. You really don't want that blowing around, so the operator will turn the dish into a position where we know the wind can safely pass through it and isn't going to cause a problem. The operator will only stop for the wind when it reaches a limit. It says they will not warn you if the wind is, they can't tell you if the wind is going to affect your data. If you're doing higher frequency, more than likely it is, so you should definitely be checking for that. And the weather can change very quickly. In most cases, if they see that the winds are picking up, they're going to warn you. They're going to say, hey, the winds are kind of picking up. We might have to stop here in a minute. I see Jordan has raised her hand. Jordan, go ahead.
Oh, yeah, sorry. I had a question about the slew rate thing, actually.
Yeah,
So,
go ahead.
yeah, so if we were doing like mapping observations, for example, where the telescope's going to be doing a lot of slowing, would the time that we're allocated like be adjusted as the semester goes on if we're in a cold part of the semester, or is it just sort of, it is what it is and you map?
So if it turns out that so in most cases having like one session, like you're not going to, as far as I know, complete a full map in one session. In most cases, if the operators write all this down and they're going to say, Tony's going to see, because he's again the scheduler, he's going to look and say, okay, maybe they didn't finish their map because of that. Or like if you say every so often you had a couple sessions early on that were the weather was cold and or they had to go to half rate, and so you didn't get to finish your map, you just have to tell Tony, and he's usually more than happy to give you more time if that's what you need. They don't want you to like put that into like the proposal and assume that it's going to happen, because that's not always going to be a thing. But Tony's more than happy to give you, he won't do it without you telling him, like he might not realize it. So you should definitely tell him, definitely email your project friend or him if you know his email, and they will take care of that and make sure you get that time back if it affected you trying to do a map or something like that. Does that answer your question?
Yeah, it did. Thanks.
Okay. So like I said, the operators will try to stop. We'll try to let you know. Sometimes they can't do that. If suddenly they get a gust that's 70 miles an hour and the thing only goes up to 60, they're going to stop you. And they have to wait 15 minutes before they can start again. So they have an alarm in there. They have so many sounds that go off. They have a different alarm for the wind regulator that tells them, okay, it's too high, you have to stop. And so then that timer has to go for 15 minutes before they'll start again. And then here I say about how if it reaches below -10, they will shut down the telescope entirely. Go ahead, Jesse. Other frequently asked questions, blanking. If a lot of your data is being blanked, that usually means that your switching frequency is too small. There is a table in the observer's guide that will tell you what the minimum, in this case for when you've written your script in the config file, it's an SW per. It tells you what each Vegas mode or what that value should be minimum for each one of those Vegas modes. And so you should actually take a look at that. I actually have, not here, I don't, but in my office in the building, I actually have that printed out on the side of my wall so I can just turn around and look at it. If you don't think you're reaching your desired sensitivity, effective integration time is not the same as observing time. And so there's the little equation you can kind of do on your own to verify that everything looks good or everything makes sense. Go ahead, Jesse.
That's it.
That's it. I done. Anybody have any other questions? Even if I didn't cover it, if you have any general questions, I've done both forms of support. I've been the operator. I've been the on-call support person. You can ask me anything. I can maybe answer it, or I can make up an answer if I have to. All right. I think we are done.
Okay, thank you very much, Amber and Jesse.